Hello students, in previous lecture we discussed about semantic analysis and I introduced you with basic logical form language where we studied the word senses, how they can be represented with atoms or constants, constant which can be either terms, predicates or prepositions used to where the predicate followed by an appropriate number of terms to serve as its argument. We also see in the different types of predicates either in unary, binary or n-ary. Proper nouns that could be treated as terms, common nouns can be treated as unary predicates and the verbs which can be n-ary predicates. We also see the logical operators like not to represent the negative things in sentence like Sue does not love Jack, that can be represented as not loves one, Sue one, Jack one. Then we have also seen the connective proposition like or. Now we will be discussing with the quantifiers. Here you can see the sentence that is a man entered the room, he walked over to the table. Now in the first sentence a new object is introduced, that is a man, and that man introduced existentially in the first sentence is referred by the pronoun he in the second sentence. So variables appear to continue their existence after being introduced. So if you want to represent this type of scope, we will require the quantifiers. The quantifiers can be, some of the quantifiers are listed here like the, bear, where the is like a definite reference. For example, the dog. So we are talking about the specific dog. Or a dog, which has an indefinite reference. In general, we are talking about dogs. Same thing, a noun phrase with a bare singular form like water or food, or a noun phrase with a bare plural form like generics like a dogs. So let's take an example that if you have a sentence, most dogs bark. So if we want to represent it in a logical form language, how we will be representing it? Like dogs. So most dogs barks. So dogs. So dog will be represented by dog one as a keyword. So dogs, those barks. So barks who? D1, dogs, and most of the dogs, that is D1. The D1 represent dog barks, dogs bark, that is most will be attached with it. This means that most of the objects D1 that satisfy dog 1 D1 also satisfy barks 1 D1 will represent this most dogs bark. So you must have understood how the logical form language represent this sentence. Now if you reverse the sequence of dog and barks, will it affect the meaning of the sentence? See this. So you have the next logical form, that is barks 1 D2, dog 1 B2 D2. So here what it is saying, so most barking dogs or most barking things are dogs, which is representing a different meaning. So first we are saying that barking things are there who are dogs and most. So most barking things are dogs. So that's why we have to generalize this type of things with the quantifiers. So quantifiers could be the. So if we have a sentence, the dog barks. So that how you will represent it? That is dog 1 as X, barks 1 as X, and the dog barks. Okay. The second example could be the happy dog barks will involve a restriction that is a conjunction that only happy dog barks. So how you will represent it? The quantifier could be here as the and. So and operator here you can see that only the happy dogs barks. That's why you have dog X who are happy. So dog X, those are happy, barks, and all this with the. This will be true only if there is contextually unique X. So you can observe these X are common here, such that and dog 1 X, happy X is true and this X barks. So you can see here dog 1 and happy 1 has this and operator. So both the conditions should get satisfied, that happy dogs bark and the. Okay. So same thing is represented here as quantifiers. So now we'll see the predicate. So predicate operator is introduced that takes a predicate as an argument and produces a new predicate. We have seen the predicates, but predicate can have one more predicate. So that predicate could be to represent the singularity or plurality of the operator. So for representing plurals, the predicate operator is plur. If dog 1 is a predicate that is true of any dog, then plur dog 1 is a predicate that is true of any set of dogs. That means if you have a sentence, the dogs bark would be the X plural dog 1 who are X and barks X, then the. So here initially you have dog D1. Those are plural. So to represent that we can use this plur predicate. But with this plural you can have two types of ambiguities which can form. That is, when you are saying the dogs bark, is that there is a specific set of dogs and each one of them barks. So if you want to say that, this is called as a distributed reading, that a set of dogs are there and all are barking, since the predicate barks 1 is distributed over each element of the set. Whereas if you have a sentence, the dogs mate at the corner. In this case, it makes no sense to say that each individual dog mate rather than the meeting is true of the entire set of dogs. So here we can say that all the dogs who came together have a collective meeting. So it is called as collective reading. Some sentences allow both interpretation and hence are ambiguous. For example, two men bought a stereo. Now this means whether each bought a stereo, two men each bought a stereo. If it is the case, it can be a distributed reading, or that two men bought a stereo together, it is called as the collective reading. So now we'll think of the, what we can say is modal. Now what is modal? So we can say the modal operator looks similar to logical operators but have some important differences. Now what are those? So terms within the scope of a modal operator may have an interpretation that differs from the normal one. So for example, let's say Jack. Jack is a person who is also known as a John to some people. So there are two word senses that are equal, that Jack is the same person whose name is John also. But with a simple proposition, it doesn't matter which of these two constants is used. So if you are saying John is happy, so happy John 22 is true, then happy Jack 1 is also true, and vice versa. This is true even in complex proposition formed from the logical operators. For example, that happy John or sad John is true, then so is happy Jack or sad Jack is also true, because John and Jack are both are of the same person's name. But the same proposition within the scope of the modal operator, such as believe, are not interchangeable. So, if we have an operator called as believe, so if Sue believes that Jack is happy, so how we will represent it? As believe Sue, happy Jack. Okay, then it does not necessarily follow that Sue believes John is happy. That is, believe Sue happy John 22. Now, why it is so? If we are saying that Jack and John are both are the same person, because Sue might not know that Jack 1 and John 22 are the same person. Thus, you can't freely substitute equal terms when they occur within the scope of modal operator. So, here the modal operator plays the role. So, here you can see that believe is some kind of mode where the equal terms cannot be substituted. Here, this type of thing is called as failure of substitutivity in modal context. Next is the form, that is the tense. An important class of modal operators for natural language are the tense operators. So tense is also one kind of modal operator where we have three tenses: past tense, present tense and future tense. It is used to represent the difference in meaning between John sees Fido, John saw Fido and John will see Fido, which are the prepositions. So how you will represent it? You can have sees 1, John 1, Fido 1, present tense. In present tense, sees 1, John 1, Fido 1 in past tense, and future sees 1, John 1 and Fido 1 in future tense. So here also, if you can observe, here it has a failure of substitutivity. Why? Because if you have an operator past and assume two constants, that is say John 1 and precedent 1, that are equal now. So like John is a precedent right now, but indicating that John is currently the precedent, but in the past John was not the precedent. So John 1 didn't equal to precedent in the past tense. Given this, the fact that John saw Fido in the past, that is past sees 1, John 1, Fido 1, you can't conclude that precedent saw Fido in the past. That is, past sees 1, precedent 1, Fido 1 is not true, since John was not the precedent at that time. So here you can see the concept of failure of substitutivity. Similarly, a proposition and its negation can both be true in the past, but at different times. Now, how we'll see that? Let's say, thus, if we have a sentence called as John was happy and John was not happy, if both the sentences are true in the past, it can be, because but at the different times. So, past happy John and past not happy John are both true. Now we'll see if we can represent the quantifiers in generalized manner. Constructs such as generalized quantifiers are treated syntactically like terms and appear in the position indicated by the syntactic structure of the sentence. Now what do you mean by this? So for example, if we have a sentence, every boy loves a dog. If you want to represent this, it can be represented by this type of logical form: every B1, and B1 is nothing but boy. Then a dog. Dog is D1, a dog, and loves. Every boy loves a dog. Okay. So this abbreviates an ambiguity between the logical form like this: every B1, boy B1, a D1, dog D1, loves B1 D1. We can represent it like this. Or it can be represented like this also, that a dog, every boy loves. So there is only a single dog that every boy loves, or every boy loves one of the dogs. any of the dogs, like that. But there is an ambiguity, so that can be represented or resolved using this scope type of operator, that is generalized quantifier. Here we have combined this every boy together. So every boy loves dog. That can also be represented like this. So if we have this logical form, every b1 boy v1 can be abbreviated as every b1 boy. So both the logical forms are similar or same. Now we will be discussing about encoding ambiguity in the logical form. Now we have discussed that every word have multiple senses. So each sense may have different structural properties. So they can be eliminated given the context of the surrounding sentence. So if we build a separate logical form for each possible combination of senses for the words in the sentence, we can remove this ambiguity. That is nothing but encoding ambiguity in the logical form. For example, I had given you the example of ball in my previous lecture. That is, the ball has at least two senses. What are they? The object used in games can be represented by ball 1 and ball 2, the social event involving dancing. Thus, the sentence, Sue was the ball, is ambiguous out of context. So a single logical form can represent these two possibilities like this. So if you have this ambiguous sentence, that is the ball B1, and we have given either ball 1 or ball 2 is as B1, and what? Watch the ball. So watch 1 should be in past tense, Sue 1, B1. Now this is creating the ambiguity, which can be abbreviated with two possible logical forms like this. The B1, ball 1 B1. So where we are specifically specifying which type of ball. Either it is a game or a social event. So if we are saying ball 1 B1, it is a game, ball used in game. And if we are writing as ball 2, then it is a ball that is like a social event involving dancing. So this is the way how we can encode the ambiguity. Now another example could be every boy didn't run is ambiguous between the reading in which some boys didn't run and some did. So every boy didn't run, that means what? Some of the boys ran and some of the boys didn't. So how we will represent it? Like every B1, boy 1 B1, run 1 B1, and we have negate it with not, as they didn't run. But the reading where no boys ran, that is every B1, boy B1, not run 1. So it is also possible that none of the boys ran. So these two readings are captured by the single logical form like this, not run 1, every B1 boy 1, where you have used the scope operator which is with the every boy, so that it will not create the ambiguity that whether none of the boy ran or some of the boy ran. So not run 1, every boy B1. So where unscoped unary operators, for example not, past, present are wrapped around the predicate. Proper names must be interpreted in context, and the name John will refer to different people in different situations. So which John we are referring to should not be ambiguous. So we can use a discourse variable that has the property of having the specified name. So that's why we can use a proposition or a name as a operator, that is name, variable and actual name we have to present. For example, we have the logical form John ran. So that can be represented as name J1, and J1 is represented as John, who ran. So past, run 1. Similar for pronouns and other indexical words such as here and yesterday can be used. So for them, we can use a PRO kind of operator. So that is a special function called as PRO. So for we can have every man liked him. If we want to represent, that is nothing but a pronoun we want to represent. So pronouns or any indexical words can be represented with this type of pro. So every man liked him can be represented as every M1 man 1. Pronoun M2, which is nothing but he 1 M2. So he 1 is M2, which is a pronoun with who is liked by every man. So this is the way how we can represent it, the pronoun and indexical term. So he one is the sense for he and him, and formally is a predicate true of object that satisfy the restriction on any antecedent, that is being animate male in this case. So the same sentence or the same form of pro M2 he one M2 can be abbreviated as pro M2 he one. So you don't need to use two you can combine these two sentences, that is pro M2 and he one M2 into single one, that is pro M2 he one. This we have discussed. Now let's discuss about verbs and states in logical form. So consider the following sentence, that is John broke the window with the hammer. So we have three types of sentence with the verb break, and it has the different forms. So we have first as John broke the window with the hammer. Then the hammer broke the window and the window broke. All these sentences describe the same type of event but in varying detail. How it is? The verb break should be mapped to the same sense in each case. But there is a problem, as there is three cases of the verb seem to indicate verb senses of different arity. We'll see that. The first seems to be a ternary relation. You can see you have John, then the window and a hammer in first sentence. Then in second sentence we have the hammer and the window, and third we have only a unary relation, that is the window, like this. So the window broke. So these three different senses of break, how we can represent? So we have a break. So broke the window, that's why past break one. Then name J1. So John broke the window. The W1 window one. The H1 hammer one. So you have this first, the window is broken by the hammer. By who has broken it? That John. Then past break to the H1 hammer one, the W1 window one. Here John is not mentioned. And in the last sentence we have only window which is broken. So these are the three ways how we represent the three sentences having the same sense or the same event. So you have the events into the ontology treating the meaning of sentence like John broke it. So when you are saying John broke it, here we have to represent a pronoun. Okay, so which assert, so he can represent it as name J1 John, pro I1 IT1, that is 8, break, that is even. You can have before this as past, which asserts that even is an event of John breaking the indicated window. Now the meaning of John broke it with the hammer would be, you have the hammer. Here you can see there is an INSTR, that is nothing but the instrument with which we have broken the, or John has broken the window. So that can be represented with this instrument kind of operator. Then it is nothing but a pronoun which is represented by PRO. Then John is a name. So name J1 John, and brick. Now John break it with the hammer. So the name should be John who has broken it. That's why there is an and operator here. So that is J1 John broke it with the hammer. The next logical form for the sentence Mary sees John will sometimes be written as present tense sees, then agent name Mary and theme is name M1 John, which is equivalent to present tense sees L1, agent L1, name J1 Mary, theme L1, name M1 on John. Now, what do you mean by this is the Mary sees John. So, there is an agent L1 that is nothing but the theme or Mary saw whom, that is nothing but John. So, it will be written in predicate argument as like this. Name J1 Mary, name M1 John, sees present tense. So there is limited set of abstract semantic relationship that can hold between a verb and its argument. So they are called as thematic roles or case roles. And while different researchers have used different sets of roles. So here you can see that we have three things: John, the hammer, and the window. So they are playing different thematic roles or semantic roles. So here John is the actor, so that is called as the agent role. So in this Mary sees John, so Mary is the actor who is seeing something. That's why we have written here as agent. Then we have the hammer, which is nothing but the instrument. So that's why we have written as it is INSTR, and the window is nothing but the theme, that is the object which we are working with. So that is the object. This suggests a representation of sentence meaning where everything is expressed in terms of unary and binary relations. Using the three thematics rule, the meaning of John broke the window would be, you have break E, agent E who is John, theme is the window, like this. So John broke the window, and if you want to add up with INSTR, that is the hammer, you have to attach it with that particular logical form. So we have some of the similar arguments can be made for verbs other than event verbs. So Mary was unhappy. How you can show that? Name J1 Mary, past unhappy. That is a unary predicate. So this is all about how the semantic interpretation can be done using logical form language, and this is used in natural language processing for specifying or removing the ambiguity, that is semantic ambiguity, and removing the word says ambiguity can be disambiguated with this type of logical form. So here we have represented a context independent semantic interpretation called the logical form. Such a representation is desirable to simplify the process of computing semantic structures from the syntactic structure, and more generalized to modularize the processing of sentences by separating out contextual effects. So we have seen the diagram where we have seen that initially we have a syntactic structure, then we will be representing the logical form, and then we will apply or attaching a contextual interpretation to it. So the logical form language can encode many common forms of ambiguity in efficient manner, then which allows alternative senses to be listed wherever a single sense is allowed. An important aspect of the logical form language is its use of event and state variables on predicate. So we can have a additional adverbial modifiers also which can be represented in a logical form. So this is all about how we can we can have the journey of syntax to semantics to context. Thank you.